Good evening, students. I hope I am audible clearly. So we will start with the class. Now last class it will stop madidvi. That is a capacitor of capacitance. 10 microfarad is charged to 10 volt. The energy stored 500 microjoules anta bandittu namage answer. So now we will continue with the next question. Yes, I hope everybody is ready with the book and the pen. Yes. So today's attendance, that is Anvita, Jyoti, Komal, Manikanta, Manju, Nagini, Priyanka, Radhika. Okay. Yes. See, when an additional charge of 2 coulomb is given to a capacitor, energy stored in it is increased by 21%. The original charge of the capacitor is. So neat level question irutte. It will be difficult only. Direct questions in nimge astondu baralla. ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ನೋಡಿ ಕ್ವಶನ್ ಅಲ್ಲಿ and additional charge of 2 coulomb is given to a capacitor. So already capacitor ಇದೆ, capacitoral charges already ಇದೆ, but ನೀವೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಇದ್ದ ಚಾರ್ಜ್ ಅಲ್ಲಿ ಮತ್ತೆ 2 coulomb ಚಾರ್ಜ್ ಅನ್ನ ಆಡ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಓಕೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಫಸ್ಟ್ ಕೆಪಾಸಿಟರ್ ಚಾರ್ಜ್ ಏನಾದ್ರು 10 coulomb ಅಂತ ಇದ್ರೆ ನೀವು ಅಲ್ಲಿ ಮತ್ತೆ ಏನ್ ಚಾರ್ಜ್ ಹಾಕ್ತಾ ಇದ್ದೀರಾ ಪ್ಲಸ್ 2 coulomb ಅಂದ್ರೆ 10 plus 2 12 ಅಂತ ಆಗುತ್ತೆ. Then energy stored in it is increased by 21%. ಸೊ ನಿಮ್ದು ಫಸ್ಟ್ ಏನ್ ಎನರ್ಜಿ ಇರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ನೀವು 2 coulomb ಚಾರ್ಜ್ ಅನ್ನ ಅದಕ್ಕೆ ಆಡ್ ಮಾಡಿದಾಗ ದ ಎನರ್ಜಿ ಇನ್ಕ್ರೀಸಸ್ ಬೈ ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ 21%. ಆಯ್ತಾ. ದ ಒರಿಜಿನಲ್ ಚಾರ್ಜ್ ಆಫ್ ದ ಕೆಪಾಸಿಟರ್ ಈಸ್. ಸೊ ಬಿಫೋರ್ ಗಿವಿಂಗ್ 2 coulomb ನಿಮಗೆ ಗೊತ್ತಿಲ್ಲ ಅಲ್ಲಿ ಎಷ್ಟು ಚಾರ್ಜ್ ಇತ್ತು ಅಂತ, ಯು ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ವಾಟ್ ಇಸ್ ದ ಚಾರ್ಜ್, ಒರಿಜಿನಲ್ ಚಾರ್ಜ್ ಆಫ್ ದ ಕೆಪಾಸಿಟರ್. I hope the question is clear. So you have a capacitor where some charge is already there. Again you are adding 2 coulomb charge. ಅದ್ರದ್ದು ಎನರ್ಜಿ ಫಸ್ಟ್ ಏನಿರುತ್ತೆ, ನೀವು ಯಾವಾಗ 2 coulomb ಚಾರ್ಜ್ ಅನ್ನು ಹಾಕ್ತೀರಾ 21% ಅಲ್ಲಿ ಎನರ್ಜಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. ವಾಟ್ ಇಸ್ ದ ಒರಿಜಿನಲ್ ಚಾರ್ಜ್ ಆಫ್ ದ ಕೆಪಾಸಿಟರ್? ಸೊ ಲೆಟ್ ಅಸ್ ಸಿ ಹೌ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿಸ್. Yes. So we know that the energy stored in the capacitor. So we will take before adding 2 coulomb one equation, after adding 2 coulomb one equation ಬರುತ್ತೆ. So before adding ನೀವೇನಾದ್ರೂ Q ಇದು ನಮ್ದು ಚಾರ್ಜ್ ಇದೆ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ the energy stored in the capacitor is given by Q square upon 2C. Equation 1 when it is before adding that 2 coulomb charge ಆಯ್ತಾ. ಸೊ ಇಲ್ಲಿ Q ಅಂದ್ರೆ ಚಾರ್ಜ್ ಇದೆ, C ಅಂದ್ರೆ ಕೆಪಾಸಿಟನ್ಸ್, U ಅಂದ್ರೆ ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಯು ಆರ್ ಗಿವಿಂಗ್ 2 coulomb ಆಫ್ ಚಾರ್ಜ್. ಸಪೋಸ್ ಇನಿಷಿಯಲ್ ಚಾರ್ಜ್ ಇಸ್ Q, ನೀವು ಅಲ್ಲಿ ಎಷ್ಟು ಆಡ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ 2 coulomb ಚಾರ್ಜ್ ಅನ್ನ ಆಡ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಸೊ ವೆನ್ ಯು ಆರ್ ಆಡಿಂಗ್ 2 coulomb ಇಟ್ ಇಸ್ ಬಿಕಮಿಂಗ್ Q plus 2. ನಾನು ಅದನ್ನ Q dash ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ಕೊಂತಾ ಇದ್ದೀನಿ. Yes, I am denoting it as Q dash. I hope first step, second step it is clear to you. Then U dash is equal to, ನಾನು ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಎನರ್ಜಿ ಬರಿತಾ ಇದ್ದೀನಿ when you are adding the 2 coulomb of charge. So the new energy I'll take it as Q dash square divided by 2C. Equation 2. So first equation, when the energy is Q square upon 2C, first ಇದಿಲ್ಲೇನು just initial charge ಇದ್ದಾಗ ನೀವು ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಯು ಆರ್ ಆಡಿಂಗ್ ಎ ಚಾರ್ಜ್ ಆಫ್ 2 coulomb, then the charge is becoming Q plus 2. Now the new energy is Q dash square divided by 2C. Equation 2. ಆಯ್ತಾ. ಈಗ ನೋಡಿ as per the question. So here as per the question ಏನಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, here the energy is increasing by 21%. ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ ಎನರ್ಜಿ U ಅಂತ ಇದೆ, ಪ್ಲಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಆಡ್ ಆಗ್ತಾ ಇದೆ 21%. ಸೊ 21% ಆಫ್ ದ ಇನಿಷಿಯಲ್ ಎನರ್ಜಿ. ದಿಸ್ ಐ ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಆಸ್ U plus 21 divided by 100 into U. ಸೊ ಇದನ್ನ ನಾನು U dash ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ಕೊಂತೀನಿ. ಐ ಹೋಪ್ ಯು ಆರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ ನೀವು ಮ್ಯೂಟ್ ಮಾಡಿ, ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ, ಯು ಕ್ಯಾನ್ ಸ್ಪೀಕ್ ವಿತ್ ಮೀ. Okay, so I'll repeat the steps. First equation, this is the energy of the capacitor Q square upon 2C. ಯಾವಾಗ ನೀವು 2 ಕೂಲಂಬ್ ಚಾರ್ಜ್ ಅನ್ನು ಆಡ್ ಮಾಡ್ತೀರಾ, the new equation is q dash is equal to q plus 2c. then energy stored ಈಗ ಏನಾಗುತ್ತೆ, q dash square divided by 2c ಅಂತ ಆಗುತ್ತೆ. ಅವ್ರು ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, the energy is increases by 21%. so 21% increase ಅಂದಾಗ ಇನಿಷಿಯಲ್ ಸಪೋಸ್ u ಅಂತ ಆದ್ರೆ ಪ್ಲಸ್ 21% of the original. so 21% into u ಅಂತ ಆಗುತ್ತೆ. therefore it is 21 divided by 100 into u. so ಇಲ್ಲಿ ನೋಡಿ ನೀವು ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈಡ್ ಮಾಡಬಹುದಾಗಿದೆ. that is u plus 21 by 100 into u. so this is equal to here the LCM will be 100 u plus 21 u. therefore u dash is equal to 121 u divided by 100. okay, so it is 121 u divided by 100. now write the u dash is equal to. so what is u dash is equal to? now from equation 2 I am writing u dash value. what is your u dash? it is q dash square divided by 2c, u dash square divided by 2c, which is equal to 121 by 100 into u. so u value ನಮ್ಗೆ equation 1 ಇಂದ ಬರುತ್ತೆ, that is q square upon 2c. so ಇಲ್ಲಿ ನೋಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ನಾನು ಏನ್ ಮಾಡಿದ್ದೀನಿ, I am adding equation 2 and equation 1 in this equation 3. I hope you understood this step. so ನಮ್ದು ಏನ್ ಬಂದಿದೆ ಇಲ್ಲಿ, ಎನರ್ಜಿ 21% ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. therefore it is u plus 21% of u. next 21% ಅನ್ನ ನಾವು 21 divided by 100 into u ಅಂತ ಬರ್ಕೋಬಹುದಾಗಿದೆ. therefore it is becoming 121 u divided by 100. ಆಯ್ತಾ? ಸೊ ಇಕ್ವೇಶನ್ 3 ಆಗತ್ತೆ. ನಮ್ಗೆ ಇಲ್ಲಿ ಇಕ್ವೇಶನ್ 3 ದಲ್ಲಿ ಏನಿದೆ, u dash ಮತ್ತೆ u ಅಂತ ಇದೆ. ನಮ್ಮ ಹತ್ರ ಇಕ್ವೇಶನ್ 1 ಮತ್ತೆ 2 ದಲ್ಲಿ u dash ಮತ್ತೆ u ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ. ಸೊ ನಾ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂತ ಇದ್ದೀನಿ. yes, so now you go on simplifying, you will get the final answer. okay, let us simplify this. that is, see here 2 and this side 2. so ಎರಡು ಕಡೆ ಇದೆ 1/2 ಏನಿದೆ ಇದು ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಕೊಂತ ಇದ್ದೀನಿ. yes, similarly I can cancel this c also. q ಮತ್ತೆ q ಕ್ಯಾನ್ಸಲ್ ಆಗಲ್ಲ, ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ q dash ಅಂತಿದೆ, ಅಲ್ಲಿ q ಅಂತ ಇದೆ. therefore now I have q dash square is equal to 121 by 100. ಯಾರಾದ್ರೂ ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲಿ ಸ್ಪೀಡ್ ಇದ್ರೆ ನೀವು ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು ಇಲ್ಲಿ. okay, so it is q dash is equal to 121 divided by 100 into q square. so what it is, 121 divided by 100 is nothing but what, this is 10s, this is 11s. so therefore it is 11 divided by 10 into 11 divided by 10. so instead of this you can take the square root, sorry, okay, will cancel agalla. it is 121 divided by 100 alla. yes, square ಇದೆ, ನಾನು ಏನು ಮಾಡ್ತೀನಿ ಸ್ಕ್ವೇರ್ ರೂಟ್ ತಗೊಂತೀನಿ ಇಲ್ಲಿ. okay, so because ನೀವು ಇಲ್ಲಿ ನೋಡಬಹುದು ಸ್ಕ್ವೇರ್ ರೂಟ್ ತಗೊಂಡ್ರೆ 121 ದ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಎಷ್ಟಾಗುತ್ತೆ, 11 ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ 100 ಸ್ಕ್ವೇರ್ ರೂಟ್ ಎಷ್ಟಾಗುತ್ತೆ, 10 ಅಂತ ಆಗುತ್ತೆ. so therefore here square will go and here it is q dash. so if you are not understood this step, I'll write it once again. that is taking square root on both the side. so therefore here it is q dash is equal to 121 q dash is square root is it is 11 and 100 square root is it is 10 and it is q. okay, now let us simplify this one. so cross multiply, it is becoming 10 q dash is equal to 11 q. it is 10 q dash is equal to 11 into q. so what is q dash value? here you can see this from this step. so what is q dash here? q dash is q plus 2. so substitute here, that is 10 into, so q dash is q plus 2 which is equal to 11 into Q. So further, can you simplify this? We require only Q value. Yes, ಯಾರಾದ್ರೂ simplify ಮಾಡ್ಬೋದಾ ಇಲ್ಲಿ? So Q dash, I am taking Q is plus 2 ಅಂತ. So Q plus 2 ಅಂತ ನೀವು ಇಲ್ಲಿ ತಗೊಂಡು simplify ಮಾಡ್ಬೋದಾಗಿದೆ. Yes, somebody got the answer. 20. Yes, 20. Yes, correct. Very good. Yes, option D. Solution is clear to everyone? Yes, Manikanta, Komal, Jyoti. Priyanka, yes. Very good. Solution is clear? Yes. Okay. Meghna, Nagini, I hope everyone is solving. You should get answer option DC. So each and every step is solved here. You should get the answer option D. I'll go for the next question. I hope everyone is getting the answer. The next question is, okay, see, a small oil drop of mass 10 to the power minus 6 kg is hanging in at rest between two plates separated by 1 mm, having a potential difference of 500 volt. The charge on the drop is, so what is this question? That is a small oil drop of mass 10 to the power minus 6 kg. So mass is given. First write down the mass. Mass is equal to 10 to the power minus 6 kg. Is hanging at rest between the two plates separated by 1 millimeter. That is the distance is equal to, it is 1 millimeter. Convert it in terms of meter. It is 1 into 10 raised to minus 3 meter. Having a potential 500 volt. Therefore, the charge on the drop is. So capital Q, small q. ಯಾವ್ದಾದ್ರು ತಗೊಳ್ಳಿ. Yes. So ಅವ್ರು ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ? The charge is remaining at rest. The charge is remaining at rest. So when the charge is remaining at rest, what does it mean? So rest ಅಲ್ಲಿ ಇದೆ ಅಂತಂದಾಗ ಏನ್ ಆಗ್ತಾ ಇದೆ? ಇಲ್ಲಿ ಎರಡು ಫೋರ್ಸ್ ಬ್ಯಾಲೆನ್ಸ್ ಆಗ್ತಾ ಇದೆ ಅಂತ. ಯಾವ್ದು? That is force on the drop must be equal to weight of the drop. Force on the drop must be equal to weight of the drop. Okay. So force on the drop. So what is force on the drop? ನಿಮಗೆ ಗೊತ್ತಿದೆ in terms of electric field ಆಯ್ತಾ? That is electric field is equal to force upon charge. Sorry. It is force upon charge F divided by Q. Therefore force is equal to, it is becoming E into Q. So I'll substitute here E into Q. Weight andre ನಿಮಗೆ already ಗೊತ್ತಿದೆ. That is nothing but what? mg. Correct? So keep this Q as it is. We know one more relation. ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ನಾವು ಮತ್ತೊಂದು ರಿಲೇಷನ್ ಕಲಿತೀವಿ. That is the relation between electric field and the potential. ಏನಿದೆ ಹೇಳಿ? That is V E is equal to V divided by D. So ನೀವು derivation ಕಲಿತಿರ್ಬೇಕಾದ್ರೆ, so ನೀವು dou E is equal to minus dou V by dou X ಅಂತ ಹೇಳಿರ್ಬೋದು. So ಬೇರೆ ಬೇರೆ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಸಿಂಬಲ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. But I have taken in general the electric field as E, the potential as V, and the distance as D ಅಂತ ನಾನು ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Okay. So minus we don't consider, we just consider the magnitude. Minus sign we don't require here. Yes. Substitute the value of electric field now. That is what? V by D is equal to M into G. Now can you everyone simplify it for Q is equal to? Solution ಅಂತೂ clear ಆಗಿದೆ. The drop is at rest. So drop is at rest ಅಂದಾಗ ಏನಾಗುತ್ತೆ? Two forces are balancing. ಯಾವ್ದು? The force on the drop and the weight of the drop. Force on the drop ಅನ್ನ ನಾವು electric field equation ಇಂದ ತಗೊಂತಾ ಇದ್ದೀವಿ. That is EQ is equal to F. Then weight of the drop is, it is mg. then Q is equal to, it is V divided by D. Therefore Q is equal to, so iದೇನಾಗುತ್ತೆ ನೋಡಿ, Q is equal to mg into D divided by potential ಅಂತ ಆಗುತ್ತೆ. You can substitute. Question ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ what all quantities are there. Mass is 10 to minus 6 kg ಇದೆ. Acceleration due to gravity ಕೂಡ ಅವರು 10 ತಗೊಳ್ಳಿ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. So take it 10 so that simplification will be easy. Next, distance 1 millimeter. I told you already, take it 10 to the power minus 3. Then the potential is 500 volt. So simplification is not much complicated. Yes, students. Yes, somebody got the answer. 3 students. D. C. Manju is getting C. Jyoti and Priyanka is getting D. Answer is A. B baratte. 2 into 10 raised to minus 11. Check ಮಾಡಿ ಮತ್ತೊಂದ್ಸಲ. Powers check ಮಾಡಿ. Yes. Option B. Check with the power, students. If you want me to solve, I'll solve. ಬರ್ತಾ ಇದೆಯಾ? ಆಪ್ಷನ್ ಬಿ ಬರುತ್ತಾ? ಪ್ರಿಯಾಂಕಾ, ಜ್ಯೋತಿ ಚೆಕ್ ಮಾಡಿ.
Yes, sir. Yes, ma'am. Decimal point will right side shift ಆಗ್ತದೆ.
ಹಾ. Okay, I hope everyone is getting the answer. So we have 11 students today. Yes, Mahalakshmi, Meghna, Nagini, ಎಲ್ಲರೂ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ರಾಧಿಕಾ, Kausif, please solve it. So each and every step is clearly written. ಒಂದ್ಸಲಿ ನಿಮಗೆ ಫಾರ್ಮುಲಾಸ್ ಎಲ್ಲ ಬೈ ಹಾರ್ಟ್ ಆಯ್ತಂತಂದ್ರೆ ಇಷ್ಟೆಲ್ಲ ಸ್ಟೆಪ್ಸ್ ಅಂತ, you can just solve it in the 2 steps only. So first we will finish the portion with the synopsis with questions. ಒಂದ್ಸಲಿ ಇದೆಲ್ಲ ಮುಗಿದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡೋಣ, we will make it like a crash course. ಅವಾಗ ಏನ್ ಮಾಡ್ತಾ ಹೋಗೋಣ, ನಿಮ್ಗೆ ಈಗೆಲ್ಲ ಪ್ರಾಕ್ಟೀಸ್ ಆಗಿರುತ್ತೆ. that time we will just see the shorts. ಅಂದ್ರೆ 2-3 ಸ್ಟೆಪ್ಸ್ ಅಲ್ಲಿ ನೀವು ಆನ್ಸರ್ ಮಾಡೋದ್ರ ನೀವು ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಹಾಕ್ಬೇಕು ಅಷ್ಟೇ. ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ ಯು ಶುಡ್ ಬಿ capable of remembering the formulas. I hope it is clear. I'll clear this. I'll go for the next question. Okay, that is two concentric spheres of radii capital R and small r have positive charges Q1 and Q2 with equal surface charge densities. What is the electric potential at their common center? So what is the electric potential at the common center, they are asking. Okay, you need to write the equation in terms of surface charge density. So surface charge density, it is sigma. Aita ನೀವು ಇಲ್ಲಿ options ಅಲ್ಲಿ ನೋಡಬಹುದು. The options are sigma divided by epsilon naught r plus r. Option B, sigma by epsilon naught r minus r. Option C, option D. So let us see what we will get. First, understand the question and write it. Yes. So two concentric spheres of radii capital R and small r. So ನಿಮ್ಮ ಹತ್ರ ಎರಡು that is the sphere ಇದೆ. This is first sphere, this is the second sphere of the radii small r and the capital R. So I'll take the inner surface is having the radii small r and the outer surface is having the radii capital R, small r, capital R. Okay. Positive charge Q1 and Q2 is there. Okay, so Q1 and Q2 I'll take for the body R, capital R, charge Q1, and for the second body I'll take it as charge Q2. So Q1, Q2 is the charge. Next, with equal surface charge density. Suppose one body surface charge density sigma 1 ಅಂತ ತಗೊಂಡು ಮತ್ತೊಂದು 2 ಅಂತ ತಗೊಂಡ್ರೆ ಅವ್ರು ಈಕ್ವಲ್ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಸೊ ನಾನು ಅದಕ್ಕೆ ಕಾಮನ್ ಆಗಿ ಸಿಗ್ಮಾ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. What is the electric potential at the center? Question, I hope it is clear. You have the two concentric circles of radii capital R and the small r. ಅದರ ಮೇಲೆ ಚಾರ್ಜ್ ಏನಿದೆ Q1 ಮತ್ತೆ Q2 ಅಂತ ಇದೆ. Then the surface charge density is equal ಅಂದಾಗ sigma 1 is equal to sigma 2 is equal to sigma. Yes. Then the next, what is the potential at the center? So the potential at the center is given by, it is V is equal to V1 plus V2. ಯಾಕಂದ್ರೆ ಎರಡು ಸ್ಪಿಯರ್ ಅದು ಟೋಟಲ್ ಆಗಿ ಇಲ್ಲಿ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. Therefore, what is potential is equal to formula? It is 1 upon 4 pi epsilon naught Q by R. So ಇಲ್ಲಿ ನಮ್ದು ಚಾರ್ಜ್ Q1 ಇದೆ, ರೇಡಿಯಸ್ Q1 ಇದ್ದಾಗ ರೇಡಿಯಸ್ R1 ಇದೆ, ಪ್ಲಸ್ 1 upon 4 pi epsilon naught Q2 divided by small r. What is common here? So common ಅನ್ನ ಹೊರಗೆ ತಗೊಳ್ಳೋಣ. That is 1 upon 4 pi epsilon naught. Inside the bracket we have Q1 by small r plus capital R, Q2 divided by small r. ಆಯ್ತಾ? But ನಮ್ಗೆ ಆನ್ಸರ್ ನೀವು ನೋಡಿದಾಗ we require it in terms of surface charge density. So ಕೊಟ್ಟಿರೋ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ Q1 Q2 ಅಂತ ಎಲ್ಲೂ ಇಲ್ಲ. Yes, Komala is getting option A. Yes, it is correct option. Okay, so Q1 is Q1 Q2 question ಅಲ್ಲಿ ಇಲ್ಲ. ನಾವೀಗ ಏನ್ ಮಾಡೋಣ? We will just remove Q1 and Q2. Yeah, ಹೇಗೆ? By taking the definition of surface charge density. Surface charge density is equal to charge divided by area. So which is equal to Q divided by area of the sphere. I hope everybody knows this. The area of the sphere is 4 pi r square. Yes. Now, for the bigger sphere and for the smaller sphere, let us write this equation. So the surface charge density is equal to, for first sphere, Q1 divided by 4 pi capital R square. But the second sphere ige sigma is equal to Q2 divided by 4 pi small r square. ಹೌದಾ? ನಮಗೆ Q1 Q2 ಬೇಕಾಗಿದೆ to substitute in the equation. So therefore Q1 is equal to 4 pi r square into sigma, and here it is 4 pi r square into sigma, which is equal to Q2. So we have Q1, we have Q2. We can substitute in the equation and we can simplify the potential. So ಯಾರಿಗಾದ್ರೂ ಅರ್ಥ ಆಗಿದ್ರೆ ಇಲ್ಲಿವರೆಗೆ you can continue with the solutions. ಏನ್ ಮಾಡಿ Q1 ಮತ್ತೆ Q2 ವ್ಯಾಲ್ಯೂ ನ ಇಲ್ಲಿ ಹಾಕೊಳ್ಳಿ. Then common ಏನ್ ಬರುತ್ತೆ, ಯಾವ್ದಾದ್ರು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ತಾ ಹೋಗಿ you will get the answer. Okay, so I'll just teach in a slow way. ಯಾರಿಗಾದ್ರೂ ಅರ್ಥ ಆಗಿದ್ರೆ you can go with the speed. So now I'll substitute in this equation. ಆಯ್ತಾ? ಈ equation ಅಲ್ಲಿ ನಾನು substitute ಮಾಡ್ತಾ ಇದ್ದೀನಿ. It is 1 upon 4 pi epsilon naught 4 pi r square into sigma divided by capital R plus Q2 4 pi small r square into sigma divided by small r. ಆಯ್ತಾ? 4 pi is common, so let me take that out, and r square ಮತ್ತೆ r ಇಲ್ಲಿ cancel ಆಗುತ್ತೆ. So what is remaining now? So 4 pi ಕೂಡ cancel ಆಯ್ತು. Therefore sigma is common. Sigma divided by naught inside bracket capital R divided by small r. Check. ಯಾರಿಗಾದ್ರೂ ರಿಪೀಟ್ ಬೇಕಾದ್ರೆ ನೀವು ಹೇಳು, I repeat it. So we have the two concentric spheres of radii capital R and small r of the charge Q1 and Q2. Surface charge density is sigma. So the potential at the center is given by V1 plus V2. Substitute V1, it is 1 upon 4 pi epsilon naught Q1 by capital R plus 1 upon 4 pi epsilon naught Q2 by small r. Then next step, 1 upon 4 pi epsilon naught Q1 divided by capital R plus Q2 divided by small r. Then next Q1 Q2 optional illa, so surface charge density formula ಪ್ರಕಾರ ಏನಾಗುತ್ತೆ, charge by area ಅಂತ ಆಗುತ್ತೆ. Therefore Q1 is equal to 4 pi r square into sigma. Substitute Q1 Q2 in the given equation V. Simplify. Option A is the correct answer. Clear, girls and boys? Copy ಮಾಡ್ಕೊಂಡಿದ್ರೆ I can go for the next question. It's the next question. Okay, the question is, two capacitors of 10 picofarad and 20 picofarad are connected to 200 volt and 100 volt sources respectively. If they are connected by the wire, what is the common potential of the capacitors? See, ಏನಂತ ಹೇಳ್ತಿದ್ದಾರೆ, ನಿಮ್ಮ ಹತ್ರ ಎರಡು ಕೆಪಾಸಿಟರ್ ಇದೆ. One is 10 picofarad and one more is 20 picofarad. They are connected to 200 volt and the 100 volt sources respectively. So ಎರಡು ಏನಾಗ್ತಾ ಇದೆ, ಎರಡು ಕೆಪಾಸಿಟರ್ಸ್ ಅನ್ನ they are connected to 100 and 200 volt sources respectively. If they are connected by the wire, then what is the common potential of the capacitor? So what is the common potential? Two capacitors are connected to 200 and 100 volt source. Then if it is connected to the connected by single wire, common potential ಕೇಳ್ತಾ ಇದ್ದಾರೆ. So very simple formula we have, you can substitute and simplify by it yourself. So the formula is, that is V is equal to C1 V1 plus C2 V2 divided by C1 plus C2. Yes, try it everyone. So formula is C1 V1 plus C2 V2 divided by C1 plus C2. ನಿಮ್ಮ ಹತ್ರ C1 ಇದೆ, C2 ಇದೆ, V1 ಇದೆ, V2 ಇದೆ, ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಕಾಮನ್ ಪೊಟೆನ್ಶಿಯಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. B, everyone is getting B. Yes. .3 volt. Yes, correct. So remember, that is whenever you are calculating the common potential for the two capacitors, the formula is C1 V1 plus C2 V2 divided by C1 plus C2. Okay. So it is 133.3 volt. Option B is 100% correct. Next question.
Ma'am, explain this question.
Explain one second. So you have, that is two capacitors. This is 10 picofarad, and next capacitor, it is 20 picofarad. They are connected to the sources 200 volt. Okay, so separately it is connected first. That is, first capacitor is connected to the battery of the potential 200 volt. ಇದು 10 microfarad ಇದ್ದು. ನೆಕ್ಸ್ಟ್ ಮತ್ತೊಂದು ಕೆಪಾಸಿಟರ್ ಏನಾಗ್ತಾ ಇದೆ, ದ ನೆಕ್ಸ್ಟ್ ಕೆಪಾಸಿಟರ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ದ ಬ್ಯಾಟರಿ. ಇದ್ರದ್ದು ಕೆಪಾಸಿಟರ್ 10 picofarad ಇದೆ and the battery is 100 volt. Now if they are connected by the wire, so ನಾವೀಗ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ, we are taking it for the single connection. So when we are taking it for the single connection, what is the common potential for these two capacitors? So the formula is what, that is V is equal to C1 V1 plus C2 V2 divided by C1 plus C2. So V1 V2 ಅಂತೂ 200 ಮತ್ತೆ 100 ಅಂತ ಇದೆ. Next picofarad. So what is the value of picofarad? Can anyone tell what is 10 to the power of it is? Minus how much it is? 10 to the power minus? Actually it will come common. I think nobody converted this. Convert madidri? It is picofarad alla? 10 to the power?
12.
10 to the power minus 12. So picofarad ಅಂದ್ರೆ 10 to the power minus 12 ಅಂತ ಬರುತ್ತೆ. ಆಯ್ತಾ? ಆಕ್ಚುಲಿ ನಮ್ಗೆ ಇಲ್ಲಿ ನೀಡ್ ಇಲ್ಲ, ಯಾಕಂದ್ರೆ ಅದು ಕಾಮನ್ ಆಗಿ ಬಂದು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಸೊ ದಿಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು C1 is 10 into 10 raised to minus 12 into V1 is 200 plus this is 20 into 10 raised to minus 12 into 200. Sorry, this is 100, and this whole divided by, it is C1 plus C2, that is 10 plus 20, 10 raised to minus 12 ಹೊರಗಡೆ ತಗೋಣ. So 10 raised to minus 12 will get cancelled on the numerator and the denominator. Then the remaining simplification, if you continue, you will get the option B. So calculation, we will not waste much time. You can try, I can just tell you the hint. Solution is clear? Shall I go for the next question?
Yes, sir.
Okay. Okay, so see, next question is, what is the electric potential at a distance of 9 centimeter from 3 nanocoulomb? What is the electric potential at a distance of 9 centimeter from 3 nanocoulomb? Can you do it? It is direct answer with the direct formula. So we have the potential is equal to, that is V is equal to, it is 1 upon 4 pi epsilon naught Q divided by R. ಆಯ್ತಾ? So 1 upon 4 pi epsilon naught ಅಂತೂ ಎಲ್ಲರಿಗೂ ಗೊತ್ತಿದೆ ಈಗ. It is 9 into 10 raised to 9 into. So Q value, the charge value is 3 nanocoulomb. So 3 nanocoulomb ಅಂದ್ರೆ 10 to the power minus 9 ಆಗುತ್ತೆ. This divided by R, 9 centimeter ಅಂದಿದ್ದಾರೆ, ಮೀಟರ್ ಅಲ್ಲಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. Therefore it will be 9 into 10 raised to minus 2. So very simple calculation, quick. Within 10 seconds you can solve it. Option D or A? Yes, Anvita is getting A. Priyanka, check it. Option D baratta, A baratta. Yes. Priyanka, check with your answer. A baratte. Yes, correct. Okay. Others? This Jyoti, Mahalakshmi, Manju, Radhika, Tausif. So 9 will get cancelled. 10 to the power plus 9 minus 9 will get cancelled. 3 raised to minus, sorry, denominator ಅಲ್ಲಿ 10 raised to minus 2 ಇದೆ. ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ 10 raised to plus 2 ಆಗುತ್ತೆ. 3 into 10 raised to 2, that is nothing but what, 300. Simple. Yes, Adala? Okay. Let us go for the next question now. That is, the next question is, A voltmeter reads 4 volt when connected to a parallel plate capacitor with air as a dielectric. When a dielectric slab is introduced between the plates for the same configuration, voltmeter reads 2 volt. What is the dielectric constant of the material? So, see, little theory it is there. What is that? A voltmeter reads 4 volt. So you have the voltmeter. This is reading 4 volt when it is connected to a parallel plate capacitor. So you are connecting this voltmeter to the parallel plate capacitor. Next, with air as a dielectric. So with air as a dielectric, when a dielectric slab is introduced. So you are introducing a dielectric slab in between of this parallel plate. Voltmeter reads 2 volt. Now what is the voltmeter reading? It is 2 volt. What is the dielectric constant? So nivilli dielectric one slab. Dielectric slab in the sense it is like a insulating material. So it will insulating material and ittaga. What is the dielectric constant? K value. I hope the question is clear to you. You have a capacitor, parallel plate capacitor and the capacitor ide adu voltmeter connect ಮಾಡಿದಾಗ it is reading 4 volt. When you are introducing a parallel plate madhyadalli, we are introducing a dielectric slab. So when you introduce a dielectric slab, the reading is 4 volt in the 2 volt ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ. What is the dielectric constant? So I hope the question is clear. I'll tell you the solution now. Suppose we will do some consideration because the question they have not given much considerations here. If you consider V naught be the potential difference between the plates when air is there and V be the potential when the dielectric slab you are introducing. Now the relation between this V and V naught is given by, so again it is a direct formula, V is equal to V naught upon K. Therefore it is K is equal to V naught upon V. So K is what? It is dielectric constant. V naught, nanen helde V naught when the air is there. So when the air is there, what is the reading? Voltmeter reading 4 volt. When the dielectric slab you are introducing, what is the voltmeter reading? It is 2. So what about the dielectric constant? A, B, C, D. Yes, correct ala? So it is option D. 2. It is option D, 2. And it is not having any unit, okay na? Because it is dielectric constant and it is the ratio of same quantity. You will know both. It is the ratio of same quantity, that is V naught divided by V, that is 4 divided by 2 is equal to 2. So ಎರಡು volt volt ಅಲ್ಲಿ ಇರುತ್ತೆ cancel ಆಗಿ, it is a unitless quantity. Next question. Okay, the next question is, a spherical shell of radius 10 centimeter is carrying a charge Q if the electric potential at a distance is 5 centimeter, 10 centimeter and 15 centimeter from the center of the spherical shell is V1, V2 and V3 respectively. Then, this question is little lengthy. So see, in here, you have a spherical shell. Okay, this is our spherical shell of radius 10 centimeter. So this the radius is 10 centimeter here, is carrying a charge Q. It is carrying a charge Q. If the electric potential at a distance of 5 centimeter, so iದ್ರ radius till 10 centimeter ಇದೆ, 5 centimeter ಅಂದಾಗ ಏನಾಗುತ್ತೆ exactly ಸ್ವಲ್ಪ meter ಬರುತ್ತೆ, and electric potential at 5 centimeter and the electric potential at the 10 centimeter and the electric potential at the 15 centimeter. So ಇದು 15 ಆಗುತ್ತೆ. another marker I'll take. So 5 is here, 5 centimeter distance, 10 centimeter distance, 15 centimeter distance. Okay. So this is V1, this is V2, and this is V3. Okay. From the center of the spherical shell is V1, V2, and V3 respectively. Then, so now again ಮಾಡ್ಬೇಕಂತ ಅಂದ್ರೆ which the potential value is greater that we need to check. So can you tell it from the equation? You know that the potential is given by what? 1 upon 4 pi epsilon naught Q divided by R. ಹೌದಾ? ಸೊ ನಿಮ್ಗೆ ಈಗ ಡಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿದೆ. ಸೊ ಪೊಟೆನ್ಶಿಯಲ್ V1, V2, V3 ಯಾವ್ದು ಜಾಸ್ತಿ ಇರುತ್ತೆ ಕಡಿಮೆ ಇರುತ್ತೆ, you can tell it. Can you tell me what is the answer? Try at least what you will get. So here if you see this, ಆಯ್ತಾ, ಇಲ್ಲಿ ನೋಡಿ V1, V2, V3 ಅಲ್ಲಿ somebody is giving answer. So option C. Option C, okay. Option C baratta, B baratta, we will check. So let us verify this. See, if you see the potential inside and potential on the surface. So potential inside and on the surface and at outside the surface. So suppose inside the surface is equal to potential on the surface is equal to, it is 1 upon 4 pi epsilon naught Q divided by R. So what is the meaning here? ಇಲ್ಲಿ ನೋಡಿ, if you consider potential ಇಲ್ಲಿ consider ಮಾಡಿ ಅಥವಾ inside consider ಮಾಡಿ, central change ಆಗುತ್ತೆ. So if you consider the potential on the surface and inside the surface, here the potential is equal. That is 1 upon 4 pi epsilon naught Q by R. So ನಮ್ಗೆ ಈಗ ಏನಂತ ಗೊತ್ತಾಯ್ತು, according to this concept we know that V1 is equal to V2. What about V3? V3 is outside, ಹೌದಾ? So when the V3 is outside, here what is the V3? When it is outside, the potential I'll take it as 1 upon 4 pi epsilon naught Q divided by capital R. So outside ಅಂದಾಗ ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, radius value is increasing, radius value is increasing. ಏನಾಗುತ್ತೆ, potential value ಕಡಿಮೆ ಆಗುತ್ತೆ. So obviously the value is less than your V3 value. ಅಂದ್ರೆ V2 value ಜಾಸ್ತಿ ಇರುತ್ತೆ compared to your V3 value, but V1, V2 is equal. Why? Potential on the surface and inside the surface it is equal. So option D is the correct answer. So we feel it is C. C answer no doubt. But here one thing we should know, that is the potential on the surface and inside the surface it is same. Yes, everyone. So option D. I hope you are agreeing with the answer. You understood what is the solution it is. So last one more question we will solve for today and we will stop it. If you give me the permission, I will go for the next question. Okay, I hope no need to repeat it. So potential inside and on the surface it is same. Therefore V1 is equal to V2. But outside the surface it is different. But as the distance is increasing, the potential value decreases. So V1, V2 equal iddaga V3 ಏನಾಗುತ್ತೆ, ಇದೆರಡಕ್ಕಿಂತ ಕಡಿಮೆ ಇರುತ್ತೆ. I'll go for the next question. See, a particle of mass 1 gram and charge 1 microcoulomb is held at rest on a frictionless horizontal surface at a distance 1 meter from the fixed charge 2 millicoulomb. If the particle is released, it will be repelled. The speed of the particle when it is at a distance of 10 meter from the fixed charge is. So what it is? You have a particle. Will nodi. I hope you are able to see the PPT. So you have a particle of mass 1 gram and a charge of 1 microcoulomb, which is equal to 10 raised to minus 6 coulomb, is held at rest on a frictionless horizontal surface. So the distance is 1 meter from the fixed charge of 2 millicoulomb. If the particle is released, it will be repelled. It will be repelled and the plus or minus ide antartha. So it is getting repelled. The speed of the particle is So ಏನೇನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಬರ್ಕೊಂಡ್ವಿ ನಾವೀಗ ಏನ್ ಮಾಡೋಣ according to that let us take the figure. So figure is what? That is to consider the horizontal one line. So here I have a particle at this point. So this particle is having a charge of 1 microcoulomb. It is held at the rest. Okay, rest at a distance of 1 meter from a fixed charge. So again I'll consider one charge here. So these two are at a distance of what? 1 meter. These two are at a distance of 1 meter. So next. If the particle is released, so you are releasing the particle, it will be repelled. Then the speed of the particle at a distance of 10 meter from the fixed charge is. So the at a 10 meter distance of the fixed charge. So this is my fixed charge. I'll write here for your understanding. This is my fixed charge. Fixed charge value estide 2 millicoulomb anta ide. Then you have a particle which is having 1 microcoulomb value. These are at a distance of 1 meter. ನೀವು particle ಅನ್ನು ಬಿಟ್ಟಾಗ ಇದೇನ್ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ. This is traveling a distance of 10 meter. So with what speed it is traveling? Question is clear. Should I repeat it? ಏನ್ ಮಾಡ್ಬೇಕು ಹೇಳಿ? Okay, so see. You have one horizontal plane. So on this horizontal plane, you have a particle. So this particle is at rest. So this particle is at rest. ಈ ಪಾರ್ಟಿಕಲ್ ಮಾಸ್ ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ 1 ಗ್ರಾಮ್ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ ಮತ್ತೆ ಚಾರ್ಜ್ ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ 1 ಮೈಕ್ರೋಕೂಲಮ್ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ನೆಕ್ಸ್ಟ್ ಸೊ ಈ ಪಾರ್ಟಿಕಲ್ ಇಂದ 1 ಮೀಟರ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಒಂದು ಚಾರ್ಜ್ ಇದೆ. So you can consider on this side also, this side also. ನೀವು ಯಾವ ಕಡೆ ಬೇಕಾದ್ರೂ ತಗೊಳ್ಳಿ, ನಾನು ಇಲ್ಲಿ just consider ಮಾಡ್ತಾ ಇದ್ದೀನಿ. I have one more charge. This is of the value of 2 millicoulomb. Okay. ನಾವೀಗ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ? If the particle is released, so ನಂದಿದೇನ್ particle ಇತ್ತಲ್ಲ, ನಾನು ಇದನ್ನ rest ಅಲ್ಲಿ ಇತ್ತು. I am allowing it to move. So ಇದೇನಾಗ್ಬೋದಿತ್ತು? ಈ ಕಡೆನೂ ಟ್ರಾವೆಲ್ ಆಗ್ಬೋದಿತ್ತು, ಈ ಕಡೆನೂ ಟ್ರಾವೆಲ್ ಆಗ್ಬೋದಿತ್ತು. ಇದು ಈ ಕಡೆ ಹೋಗ್ತಾ ಇಲ್ಲ. ಯಾಕೆ? Because ಅವ್ರು ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, it is experiencing the repelled force. So ರಿಪಲ್ಷನ್ ಆಗ್ತಾ ಇದೆ ಅಂದಾಗ ಆಬ್ವಿಯಸ್ಲಿ ರೀಡೈರೆಕ್ಷನಲ್ ಬರಲ್ಲ, ಅದೇನಾಗತ್ತೆ ಈ ಕಡೆ ಮೂವ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಹೌದಾ? ಬಿಕಾಸ್ ಆಫ್ ದ ರಿಪಲ್ಷನ್ ಫೋರ್ಸ್ ವಿತ್ ದ ಅದರ್ ಪಾರ್ಟಿಕಲ್. ಸೊ ಇದೇನ್ ಈ ಕಡೆ ಮೂವ್ ಆಗಿ ಹೋಗ್ತಾ ಇದೆ, ಇಟ್ ವಿಲ್ ಟ್ರಾವೆಲ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ 10 ಮೀಟರ್ ಫ್ರಮ್ ದಿಸ್ 2 millicoulomb ಚಾರ್ಜ್. ವಾಟ್ ಇಸ್ ದ ಸ್ಪೀಡ್? ಎಷ್ಟು ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಇದು ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಕ್ವಶನ್ ಅರ್ಥ ಆಯ್ತಾ ಈಗ? ಸೊ ಐ ಹ್ಯಾವ್ ಎ ಚಾರ್ಜ್ 1 ಗ್ರಾಮ್ ಮಾಸ್ ಇದೆ, ಅದರದ್ದು ಚಾರ್ಜ್ 1 ಮೈಕ್ರೋಕೂಲಮ್ ಇದೆ, ಮತ್ತೊಂದು ಚಾರ್ಜ್ ಇದೆ ಆನ್ ದ ಸೇಮ್ ಸರ್ಫೇಸ್ at 1 meter distance. ಯಾವ ಕಡೆ ಬೇಕಾದ್ರೂ ಕನ್ಸಿಡರ್ ಮಾಡಿ, ಈ ಕಡೆ ರೈಟ್ ಸೈಡ್ ಅಲ್ಲೂ ಮಾಡ್ಬೋದು, ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲೂ ಮಾಡ್ಬೋದು. ಅದ್ರದ್ದು ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ, 2 ಮಿಲಿಕೂಲಮ್ ಅಂತ ಇದೆ. ನೀವೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಫಸ್ಟ್ ಏನ್ ಪಾರ್ಟಿಕಲ್ ಇತ್ತಲ್ಲ ಅದನ್ನ ರಿಲೀಸ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಆನ್ ದ ಸೇಮ್ ಸರ್ಫೇಸ್. ಇಟ್ ವಾಸ್ ಅಟ್ ರೆಸ್ಟ್, ನಾವು ಯು ಆರ್ ರಿಲೀಸಿಂಗ್ ಇಟ್, ಸೊ ಇಟ್ ಸ್ಟಾರ್ಟ್ ಮೂವಿಂಗ್. ಸೊ ಮೂವ್ ಆಗ್ಬೇಕಾದ್ರೆ ಇದೀ ಅದೇನ್ ಇನ್ಕ್ಲೈನ್ಡ್ ಪ್ಲೇನ್ ಇಲ್ಲ, ಈ ತರ ಏನ್ ಇನ್ಕ್ಲೈನ್ಡ್ ಇಲ್ಲ ಈ ಕಡೆ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಹೋಗ್ಬೇಕಂತ ಹೇಳಿ, ಹೌದಾ. ಬಟ್ ಇದು ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೇ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಯಾಕೆ, ಬಿಕಾಸ್ ಇಲ್ಲಿ ಏನ್ ನಮ್ಗೆ ಮತ್ತೊಂದು ಪಾರ್ಟಿಕಲ್ ಇದೆ, ಇದು ಎರಡದ್ರದ್ದು ಮಧ್ಯೆ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಇರೋದ್ರಿಂದ ಇಟ್ ಇಸ್ ಮೂವಿಂಗ್ ಇನ್ ದ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್. So with what speed it is moving, but it is covering the distance of 10 meter. I hope the explanation is clear to you.
Yes, ma'am.
Okay, now the solution is, we are using the principle of conservation of energy. So according to that, initial energy is equal to the final energy. So the potential, that is whatever the force experienced by the body, it is there. Let us write that value that is given by it is 1 upon 4 pi epsilon naught q1 into q divided by r1, which is equal to 1 upon 4 pi epsilon naught q1 into q divided by r2 plus half mv square. ಯಾಕೆ ಇಲ್ಲಿ ಹಾಫ್ ಎಂ ವಿ ಸ್ಕ್ವೇರ್ ಅಂತ ಬರ್ತಾ ಇದೆ, ಬಿಕಾಸ್ ದ ಅದರ್ ಬಾಡಿ ಸ್ಟಾರ್ಟ್ ಮೂವಿಂಗ್. ಸೊ ಅದೇನಾಗ್ತಾ ಇದೆ, ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ದ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇಸ್ ಅಸೋಸಿಯೇಟೆಡ್ ವಿತ್ ದಟ್. ಸೊ ಎರಡು ಎನರ್ಜಿ ನಾವು ಇಕ್ವೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಇಟ್ ಇಸ್ 1 upon 4 pi epsilon naught q1 into q2. ಸೊ ನಾನು ಒಂದ್ ಚಾರ್ಜ್ q1 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಮತ್ತೊಂದ್ ಚಾರ್ಜ್ ಅನ್ನ q ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಬೇಕೆಂದ್ರೆ ನೀವು q1 q2 ತಗೋಬಹುದು, ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಆಯ್ತಾ. ಸೊ ನಮಗೆ ಸ್ಪೀಡ್ ಬೇಕಾಗಿದೆ ಅಥವಾ ವೆಲಾಸಿಟಿ ವ್ಯಾಲ್ಯೂ. ಸೊ ಹಾಫ್ ಎಂ ವಿ ಸ್ಕ್ವೇರ್, ಕೀಪ್ ಇಟ್ ಆಸ್ ಇಟ್ ಇಸ್. ಸೊ ಹಾಫ್ ಎಂ ವಿ ಸ್ಕ್ವೇರ್, ಕೀಪ್ ಇಟ್ ಆಸ್ ಇಟ್ ಇಸ್. So remaining term transfer on the other side. It is 1 upon 4 pi epsilon naught q1 into q upon r1 minus 1 upon 4 pi epsilon naught q1 into q upon r2. So which is equal to 1 upon 4 pi epsilon naught is common and q is also common. And inside the bracket we have q1 by r1 minus. So q1 also we can take it outside, no problem. So q1 into q divided by 1 by r1 minus 1 by r2. Yes, you can simplify now. Simplify it for v is equal to. I'll erase the figure so that I can write here. That is half mv square is equal to 1 upon 4 pi epsilon naught 9 into 10 raised to 9 into. So q1 ಮತ್ತೆ q value ಒಂದು 2 milli coulomb ಇದೆ 10 raised to minus 3. ಮತ್ತೊಂದು micro coulomb ಇದೆ 1 into 10 raised to minus 6. Inside the bracket 1 divided by r1, that is 1 by 1 minus 1 divided by r2, that is 1 divided by 10, which is equal to. So ಇದನ್ನ ನೀವು ಇಲ್ಲಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ you will get it as 9 into 2, it is 18. 18 into 10 to the power plus 9 minus 9. So ಇದು ಪೂರ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, 10 to the power plus 9 minus 9. So inside the bracket 1 by 1 minus 1 by 10, this is nothing but 9 divided by 10. It is nothing but 9 divided by 10. Answer. So let's see, half mv square is equal to 18 into 9 divided by 10. Therefore v is equal to, so 2 ಈ ಕಡೆ ಮೇಲ್ ಬರುತ್ತೆ, 2 ones are, mass is 1 gram. So 1 gram, convert it in terms of kg. So it is 18 into 9 divided by 5 into 10 raised to minus 3. Option D. Yes, correct. What about others? Yes, everyone is getting option D. Yes, Mahalakshmi, Manikanta, I think Manikanta answered. Manju, Nagini, Priyanka, Mahalakshmi, Jyoti, Batta idea? Or should I simplify it? So V is equal to square root ತೆಗಿಬೇಕು ನೀವಲ್ಲಿ square root ಕೂಡ simplify ಮಾಡಿ ಆಯ್ತಾ. So you should get option D. Yes. Okay, students. So I hope the answer is clear to everyone. We will continue in the next class. Same lessons. So revise the formulas. We will continue in the next class. Thank you.